Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Your co-host, Rich Gear, here as well. And we have Derek Marshall, our special guest tonight. Thanks, Derek, for coming on.
Thank you.
Good to see you again. And
Yes.
This is going to be the Derek Show, right, Doug?
Right. And Derek has got a mathematical-based show tonight. Derek is going to talk about how special logarithms are to the creation message.
And good, you might be able to help me out because I really stunk at that in algebra.
Okay.
I was not good at algebra. Geometry I understood because it was pictorial.
Yeah.
But algebra, I was terrible. So I'm looking for you to help me out tonight. Okay?
Right. Well, actually, I wrote this show with Rich in mind, and also
Perfect.
with Doug in mind, and I full well realize not everybody is a geek for logarithms like I have been. I was interested in logarithms really too early in life. Exponents and logarithms, they give us the ability to express very large quantities using smaller, more manageable quantities. And I'm going to give you some really easy examples of that. Exponentials, or the exponents in math, is used to usually express growth or decay over time.
Okay.
And then, and we've had examples of that with COVID-19, where people have tried to model when, how many people were going to potentially be affected by COVID-19 over a certain amount of time. Okay. So that's a very common thing that we've experienced over the last year. And then logarithms are used to express the time it takes for a certain amount of growth or decay to occur. Now that's something that we've talked about on the show quite a bit, as far as a radioactive decay. What is the half-life?
Sure, yeah.
What is the half-life of a certain, like a fissile material like uranium? What is the half-life of uranium? That type of thing. Now, just a little bit of history. Well, here's another background item here, is base 10 logarithms. You may or may not know this, but those are used to characterize the Richter scale. The Richter scale is based upon a base 10 logarithm. And we have a graphic. I'm sure Doug will be able to throw up the graphic of the Richter scale. Every point on the Richter scale, the magnitude, whether if it's a 7 or a 7 on the Richter scale or an 8 on the Richter scale, what that is, it's a measure of a base 10 logarithm. And it's used to characterize how much the ground is actually moving during the earthquake.
And does it go by a factor of 10?
Yeah.
Each one? Is that what happens?
Yep.
Okay.
Yep.
All right. Because I know when you get to like a 1 or a 2 is not much. Even up to like 4, it's not much. But you get up to 6 or 7, suddenly things start happening. You get up to 8 or 9, it's really bad. That kind of stuff.
That's right.
And the lives is that it sort of like reminds me of, in a way, like, okay, compounded interest. Does that make any sense when you do?
There you go.
Am I getting somewhere?
Yeah, we're getting somewhere.
Oh, wow.
You are
Wow.
right. You are right with me.
Okay.
There's a gentleman named Napier. In 1618, he produced a table of natural logarithms, but those logarithms he actually didn't mention E, even though he was using what we're going to be talking about, the special number E. And then Jacob Bernoulli, 1668, discovered compound interest, just like you were saying.
Oh,
And
okay.
that is a good expression of E. An account that starts at $1 and yields interest at annual rate R with continuous compounding will accumulate E to the R dollars at the end of 1 year. You didn't know that.
Okay.
So continuous compound, what does that mean?
Continuous compounding means instead of when we used to have if a simple interest, you get 5% at the end of 1 year. It's compounded at the end of the year. Then you can have, we can give you a certain amount of percent for a certain quarterly compounding. Mm-hmm. But what we find is if you compound continuously, instantaneously compound, each series is infinitely small, and add all those up, you get this factor of E, which is, the number E is 2.718 approximately. So that's just a little, E is all around us, as Doug can attest as being a chemistry major. We use E in physics, we use E in engineering to estimate energy. There's a lot of, if you go into any mathematics at all, you're going to be working with formulas with E in the formula. And then we've already talked about one for, in finance, compound interest is used in that, is used for that.
Okay.
And if you have if you're an old school, like me, I used to use a slide rule. And that was based on a logarithmic scale, and in order to do simple calculations by sliding a rule back and forth.
You actually understood how those worked, huh?
Yeah, I used them all the time, and that was before calculators, so.
Yep, I had a slide rule.
Yeah.
I also worked with a slide rule. Where does E come from? Actually, Euler was a person that actually worked a lot with logarithms and exponentials, and he actually kind of, in his own calculations and formulations, was using just this E term to stand in for this number. It was easier to write E than the number, right?
Okay.
Yeah,
So they named it after, it's like E, Euler starts with E. So in his honor, because of his
Yeah.
what he's given to math.
His name is not spelled O-I-L-E-R, it's
Yes.
E-U-L-E-R?
Yeah, that's like a German
Then what you said,
pronunciation.
E-U-L-E-R?
Yeah, he was a Houston Oiler. Yeah, he was one of the Oilers. But yeah, so this first part is just saying E is all around us. It's something that it exists in our world. It's a mathematical relationship that relates for very small quantities to very large quantities. We see it in biological growth and decay curves, like when an organism grows, or when the population of organisms grow, the population tends to have a growth factor up to a carrying capacity, and that curve, all these curves can be modeled with the exponential or the natural logarithm called E. So it's something very common, but and so we ask, as young Earth creationists, we wonder, or we figure, well, how does this relate to creation? How does it relate to the Creator?
That was my next question, okay?
Yes.
Okay.
Yeah, so I anticipated Rich's question.
You did.
Okay, so, see, so the name of the show, I imagine the name of the show will be something like, who invented the natural logarithmic base E? God, man, or both? We would say God, right? Because we're creationists. We say God invented everything.
Yeah.
He's spoken word, established the
rules. Of
rules.
course, the skeptic would say, well, how do you know?
Right.
And then that would be the real basis for what you're going to talk about, right?
So yeah, so this first section was kind of saying that we've learned of E from the natural world around us, and we've come and we've estimated, come up with this number that's a practical number that we can use. It's useful to us, and it's all around us. But then we take this a little bit too far, and we want to take something that's practical and try to search it out to its end. Mm-hmm. And that's what this next section is about. How is E actually defined? And these are all true, like the Maclaurin series is a infinite series, which actually you can add an infinite number of fractions together with their factorials, and you get, if you can imagine, adding an infinite number of numbers together and getting a finite number.
Mm-hmm.
That's not intuitive, is it?
No.
But that's what this series does. In this particular series, if you add this, if you use this formula, which we can put the formula up on the board, everybody's going to be like, eek, when they see it. But this is how we define E now. But it requires infinity to actually, we have to invoke infinity to make this true. But it's mathematically proven, and this is a true way to get to E.
And it's sort of it's like the same argument for the derivation of pi, because pi is really a polygon. It's measuring a polygon with an infinite number of sides.
Oh.
And so you have infinity invoked in the calculation for pi, as well as E. And as you know, there's a special relationship between E and pi.
Right.
And
Yeah,
we're
we're gonna get that. That's Doug's favorite. I wanted to leave that for Doug to. I wanted to leave that for Doug because I have a kind of in the last section here. We have an interesting application of that. I just wanted to some other things about E that we have found is that E is a transcendental number.
And what do you mean by that?
And what does that mean? Right. So we're gonna just get into the the nuts and bolts just for a microsecond here, just for a minute, just to kind of come, E, we've really taken it to its, well, I want to say the nth degree.
Yeah.
That's bad. But transcendental means E is non-algebraic, meaning it can't be expressed as the root of a non-zero polynomial with rational coefficients. You just can't do it.
Okay.
Now, not all irrational numbers, and we'll talk about irrationality, but an irrational number is a number that can't be expressed as a ratio of two integers. So not necessarily are all rational numbers transcendental. Because square root of 2 is an irrational number, but the square root of 2 is not a transcendental number because you can stick it into a polynomial and come out with, and with the right coefficients and come out with an answer. It's algebraic.
I tell you, there's a reason.
So it gets really quick. We go from the Richter scale, which is something that anybody can understand, and kind of population growth, things that are very practical, to something that is just completely, seemingly goofy, but true. So these concepts has all been proven mathematically using ideas of philosophy, and everything here has been proven, very strictly proven to be true. But what I have found is E, this number and all the things that it means and invokes, is similar to the law that we think of in the Bible, the law that's been given to the Israelites. Did you know that there's 613 laws, not just 10 commandments, but there's actually 613
I don't know how many
laws.
there were, but
It's called the mitzvah.
Yeah. Okay.
So there's a lot of regulations and laws that you read about in the Pentateuch,
Sure.
that they have to follow, more than just 10 commandments. Everything that has to do with what to do with animals, land disputes, what to do if somebody takes your goat or somebody takes your donkey. All those things, God has given ideas of how to settle those things. You have to pay them back 7 times 7 or whatever.
Sure.
But what I found is the concept of E is very similar because it's established by the law, mathematical laws, lemmas, and all sorts of, it's built upon proof to get from one idea to the next. Everything is very, very strictly and logically proven. But E is similar to the law because one aspect of the E, or of the law, is that the law is unattainable. Salvation is unattainable through the law. It disqualifies all of us.
Tells you what's right, but we can't do it.
Nobody can fulfill except Jesus Christ was able to fulfill the law. E is also unattainable because anything that you say that's E, 2.718, was it 1828, something like that. If it goes on, that's not E. It's not E. It's an approximation of E. So any E that you would ever plug into your computer, be it 100 digits long, if you want to go 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000 digit mantissa on E, it's an approximation. Therefore, it's not E. So E is unattainable, just like the law is unattainable. Another similarity is the law stands as the whole or nothing at all. If you break one aspect of the law, you actually break many aspects of the law. So you either follow all of it or you follow none of it. E is the same way. You have to take E in its entirety, or else it's a fake. So every way that we use E, like in the first page discussion, that's not really E.
Well, how do you use E then to get to practical application if you can't obtain the real E?
That's the question. The question is this idea, this complex idea, is this really the E that we were talking about in the first part of the show, that God has shown us in the world around us, that He wanted us, that He spoke into existence as a natural consequence of how He has brought forth the creation by number, and continuously, as He says in Isaiah. Just like the law, we tend to take things too far. If we just follow the law, that's okay. But if we kind of introduce the philosophies of man and turn those into traditions of man, then we get into a trouble. We create idols. We create all sorts of false gods.
We do a lot of things in the church like that. How many accoutrements are in the church that the Lord
Right.
never told you to do, you know? Well, yeah, I even think it goes back to the garden, right, Doug? I mean,
It does.
Any time when the Lord said, don't eat of the tree, and what did Eve do? She said, we can't even eat or touch it. She added something.
That's right.
And there was never, he
That's
never
exactly
said,
my point.
you could touch it all you wanted to, just you cannot eat this fruit.
Because when she did touch it, nothing happened.
Right.
Yeah.
So, and now we know that grace, I mean, to start to think about, what else we have besides the law, we have grace. You know, and grace is God's riches at Christ's expense. That's the way I was taught how to
It's his
remember.
unmerited favor.
Yeah, unmerited,
Yeah. so-
unmerited favor.
Yeah, and we didn't
You know.
deserve it, didn't earn it, but it was given despite us, you know, not because of us. Okay?
Right.
Yeah.
Now, grace has everything to do with the good work that Jesus Christ did for us, and He bought that
Correct.
grace for us.
Yep.
And grace is a natural expression of, actually the creation is a natural expression of God's riches.
Oh, okay. Yeah.
So that kind of raises the question. When we've looked at creation, we see this number E. Is it plausible that we would be able to see this number elsewhere in the Word of God, actually demonstrated in the Word of God?
Now we get to it.
Now we're getting into where the rubber meets the road.
Right.
You know, and I've identified some examples of E in the Bible. Okay, so one example is, and we'll start out with the patriarchal decay age. You know that, and Rich is really good with these. The patriarchs, the ages of the patriarchs. You know, the people used to live almost 1,000 years,
Sure,
950 years, I believe, for Noah, or what are some of
Yeah,
these ages?
there's two exceptions. One, he was translated to that was
Enoch.
Enoch, and then Lamech.
Yeah.
It was 777. All the rest of them, there was one that was 895 years, but all the rest of them were 930 or 910, and some Methuselah, of course, 969, and there's.
And this was before the
yeah,
flood, but then
before
after the flood, as we read genealogies and go through reading after the flood,
Shem
we
was
see
600.
the ages that these people lived tend to started dropping off.
Very drastic.
And there's been a couple scientists that have taken a look at this curve and have determined that it's a exponential decay curve, E. It's a you can model it with E.
Wow.
So either the person that was writing that just happened to be a mathematician and knew how to write the right sequence of ages,
Right.
you know, so you could have this nice curve, or you have E.
Now, I have a question for you
Sure.
concerning logarithmic spirals. Is that the logarithms plotted on polar coordinates? Is that how that works?
Yep, that is a way that you can plot a logarithmic spiral. And also, a thing that you can do every time, if you have what's called a self-similar logarithmic spiral, every time it makes a turn, its radii, or its radius function, increases by a factor of E.
Oh, really?
Yeah.
Okay.
So every time you have one complete 360 degree rotation, the amount that the spiral has gone out away from the center, that radii is E greater, or E times greater than the last one.
So is this the real E or the theoretical E?
This is theoretically. It's not E, right? Remember, anything
Yeah.
that we can count or practically that's algebraic that we can talk about, and we're talking about this as an approximation.
And you see this in nature, in the sunflower, and the way that a lot of plants grow, and I've got some examples of
Your
that.
favorite's that filigree seed, right? Or
Yeah, filigree seed.
Filigrey seed, yeah.
So what I've done with this idea is if you start with what you call a harmonic series, which is an infinite series. It's not a series that converges to E like the Maclaurin series I talked about before. But if you take a harmonic series and you run it out and you put it on a spiral, every time the spiral rotates, once again, you get a logarithmic self-similar spiral, which for every rotation, if you count every rotation as a day, just like a rotation of the Earth, or at the time, the focus was creation, so a rotation of creation. If you do that rotation 7 times, and you keep track of what the radii was every time you cross the 180-degree line, from like the day-night line that you have in the middle.
Okay.
One side of the circle is day, the other side is night. If you keep a table of numbers as you pass these, that table of numbers corresponds to things like the periodic table of the elements, corresponds to the Fibonacci series, and all sorts of things that we've observed in the natural world. So that with that spiral the way it is, if you can use the spiral in this harmonic series to model or make a basis model of the 7-day creation. Okay, so what we have so far is we have E that's shown in the patriarchal decay curve, decay model. We have a potential model using E to model the 7-day creation that produces a table of numbers which corresponds to things that we've observed, periodic table. Then here's the really, really super good one. If you look at the Genesis timeline and pull the dates right out of the Bible, the dates that this, on the 17th day of the second month this occurred, the 17th day of the seventh month this occurred.
That's the flood, yeah.
Somehow, for some reason, the author gave all these dates. So if you just take those dates, none of the other stuff, and you compute the number of days between these events that's literally talked about in the Bible, and you make another table of numbers, every one of these numbers with its preceding phenomena is also approximates E. And here's some examples. He had a 150-day interval. 40 of those days are a part of the 150, so it also gives you a 110-day interval. So if you take the fraction 110 over 40, you get 2.75 compared to 2.78, 2.718. If you take the 197 days that occurred from the first day of that year of the flood till when the ark comes to rest, and then you divide that by the 73 days from that when the ark comes to rest to the first mountaintops, 197 divided by 93 is 2.70, which compare that to the 2.718 approximation of E. If you take, there's a special 244 day, which is if you take the 150 days plus the 73 days plus the 21 days of the birds, 7 days back and forth, 3 times.
Oh, yeah, right.
The 244, which I called, this is actually the time from the first death to the first life. That I call that 244 days divided by 90 days, which is the time from first seeing the mountain tops to removing the hull, which would be the first day of the 10th month to the first day of the first month of the next year. 244 divided by 90 is 2.71 compared to 2.718, which is E. And then there's another one. If you take the third drying period, which is 57 days, which is the first day, first month, to the second month, 27th day. If you take that 57 days and you divide it by the 21 days of bird flight, you get 2.71.
Now, then the question is, this seems
Those
like
are all
this-
approximations
This whole
of the-
thing is like a
And
design.
it goes more than that, but it's beyond the scope of the show.
Yeah, but everything it's like in a normal, if you I would say almost atheistic worldview, these things just happen. But this it's all been calculated out.
Once again, like
Fit this whole thing.
I gave the
depth-
example of the author would have to be a mathematician to be able
And then
to set up these
just
numbers.
put in fake dates or
Yeah.
put in whatever dates would
Yeah.
fit the fact. Okay. And why would you do that?
Yeah.
I mean, there's really not even any sense of it. You think about it. But then you're one. But the Lord is like putting something in here, so that somebody like you wouldn't be somebody like me, Doug. Mm-hmm. Maybe you, but not me. But could actually figure this out. I'm sitting there going, I'm sort of flabbergasted, not because I understand everything in here yet. I sort of get what you're doing, but I'm still like, my brain is kind of like, wow. But what I'm getting out is this design element that fits these things that mathematicians independently are thinking they're independent, whatever, have come up to these conclusions about E, something called E, which is this constant, or this
Right.
whatever.
But let me be my own devil's advocate here.
All right.
And
Go
this
for
is
it.
from, unfortunately, a paper I sent in and was rejected because of this idea. And this is if E is irrational, I'm developing E with ratios. Therefore, it's not E. Right? Same thing with my creation function here. That's developed through ratios. Ratios of every time the circle goes around, hits the line. It's a ratio. You have a number, then you put it over another number,
So are you
and you get
saying
an
that
approximation
you are
of E.
being rational and your reviewer is irrational? Is that what
Yes.
you're saying?
Yes, he said it's not E.
Uh-huh.
It's not E. Maclaurin series.
Yeah, well, you can't get to E anyway.
Yep, you can't. Yeah, it can't be E because you're using ratios.
Well, I know, but you're saying, are you using ratios? Can you make the argument you're using things that are rational and real to show you something that is beyond real? That is what a creationist would see.
Yes.
You see what I'm saying?
You are. Yes. You're
I'm-
cooking with gas. right now.
Yeah, you're using
That is
something-
the whole point of the show.
because this is how God wants to reveal himself in his creation, even mathematically, even though we can't obtain it or get there by rationality, we can
Human
approximate
rationality, yeah.
and we can see that these the only way to do you do by things that we can understand ratios, we can get to this approximation,
Yeah.
knowing it's an approximation, knowing we can never get to God in this material universe. We cannot get there, and even mathematically, whether it's whether it's corporeal or non-corporeal, ratio or theoretical or mathematical, we can't get there. It's like,
Right.
and I think your point earlier about trying to obey all the law. You
Yeah.
disobey it in one, you've
Right.
disobeyed the whole thing. Well, that's the same thing you're getting here. You've disobeyed that one cardinal
Yeah.
principle,
You've
that's
really,
that's the whole point
you
of
brought
it.
it around. Remember how even though Christ fulfilled the law still accused Christ.
Right. So that's the thing you put in a paper, say, yes, I know this.
Yeah.
Okay, that would be awesome.
E accuses this.
Yeah. Man. Because I would point that right directly out and say, yes, this is the point.
Yeah.
I'm using this, and you can't use it, but you have to use it.
Yeah.
Because that's
The
how we
guy-
as mortals
the
are.
reviewer hit me square. It's the best criticism of the creation function I've received. It hit me right in the stomach.
But
Hit me
that's
right between
perfect,
the
though.
eyes.
That's absolutely
It
perfect.
knocked me out for like, and basically, I also heard my mother just about the same time as when my mother passed away. So I'm in a daze, right? I'm in a
Oh, yeah,
one
yeah,
daze,
yeah.
not to bring in all poor me. But I'm like, what am I going to do with this? I just put it away for a while. I was like, boy, this guy really
But I
got me
think
with that.
saying
You know?
that, acknowledging that
Right.
truth, is exactly the point of the paper.
Yes.
Right.
That is powerful.
Yes, it is.
All right.
I mean, I
That's
get
what
all the
learned.
stuff, but
So
I get
when
that
Doug
concept.
said, hey, I think it's time to do a directional. I was like, man, I don't know.
That's great.
Then I thought, you know what? I need to get off my butt and start answering this guy.
That's great.
Yes.